All right, so I'm recording this so I can post it later. Given the inequality 5x plus 2y is greater than 10, answer questions 1 to 7. State this in rearranged form. That would quite simply just be moving stuff around. We divide everything by 2. So y is greater than negative 5 over 2x plus 5, right? That would be the rewritten form. So you get 1 mark there if we would have taken this in. State the x and the y-intercept. To get the x-intercept, I would just go 5x is equal to 10. Divide both by 5. X is equal to 2. So it's 2, 0 that we're after, right? 2, 0 is what we're after. The y-intercept, we already get it from here. So if you just write 0, 5, that's fine. Because that is our y-intercept up here. Would this line be solid or dashed? There's no equal under the inequality, so this would be a dashed scenario. Would this line go up to the right or left? So would it be going up to the right like this, or would it be going up to the left? So basically, does it have a negative slope or a positive slope, right? And it has a negative slope. So in this case, it's worded in an interesting way, to say the least, right? But it would be going up to the left, right? Line goes this way. Right? It goes up to the left, if you want to put it that way, down to the right, right? So in any case, it looks like this because it has a negative slope, right? For reverse shading, would you shade above or below the line? So remember, y is greater. This is telling us that the true region is above the line. And if we're doing reverse, we're shading the false. So we go below the line. Y is greater means, right, that above is true. We shade below. False region, right? So in this case, you'd have to shade below. Is 4, 4 part of the solution? You plug that into the original, right? So, and then you check 5 times x, which is 4, plus 2 times y, which is 4 as well. Is that greater than 10? So this would be 20 plus 8, that'd be 28 is greater than 10. So yes, because this is true, yes, it is a solution. So you'd have to plug it in and actually see if it is if that in fact makes the inequality true. Okay. Next, we have Ms. Yosik. It takes 30 minutes to mark an applied test, 9 minutes to mark an applied quiz. She can only mark a total of 3 hours before losing her mind and needing a break. In this case, they let you know what X and Y is, right? X number of tests, Y is the number of quizzes. We should add that this is, well, we'll answer that in 10. So, but this is discrete, right? Number of, you need a whole number of tests, whole number of quizzes. Okay, write the inequality for the above scenario. Because the time for a test and a quiz is given in minutes and the restriction is in hours, we have to convert the hours to minutes. That'd be the easiest, right? So 3 hours is going to be 180 minutes. Okay, so the restriction would be 30 times x, right? 30 minutes to mark a test, and it takes 9 minutes to mark a quiz. That has to be less than or equal to 180. You can't put 3 here because then it'd be less than or equal to 3 minutes, which is, you can't, right? It has to be all in minutes. or all in hours. So you could have put down 0.5, right, for half an hour. You convert this to an hour, 9/60, but that's rather complicated. It's easier to just turn it all into minutes. So this would be the inequality in this case. State your implicit constraint. That is simply this one, right? That x and y are both equal, greater than or equal to 0. You could also just say this, right? Like have two separate brackets where you indicate both of them. And so in a sense, those are two lines, right? One goes along the y-axis, the other one goes. That's why when a line touches here, these, right, like let's say this is your solution, the intercepts would actually be part of the corner points in this case if it's a word problem, okay? Discrete or continuous, this is definitely discrete, right? Because it's not saying number of minutes, it's number of tests, number of quizzes. State the y-intercept. So the y-intercept here, right, if you just go by that, it would be 9y is equal to 180. You divide both sides by 9, y is equal to 20, right? So 0.20 would be your y-intercept. X-intercept, you get 30, x is equal to 180. All of these numbers work out quite nicely. X is equal to 6 or 60, right? There it is. Always using this original one here. Is 5(3) part of the solution? In other words, is marking 5 tests and 3 quizzes, is that gonna satisfy the restriction? Well, let's check. So 30 times 5 plus 9 times 3, right? So 5 tests, 3 quizzes. Is that less than or equal to 180? This gives you 150 here, and this gives you 27, right? I'm running out of room, but this would be 177 is less than or equal to 180. So yes, it is part of solution. Okay, you can write it that way. That's how you, if a question like that is ever asked, plug it in. If there are more than one, right? Like if you have 1, 2, or 3, then you have to plug it into all of them, all of the inequalities that are present, and it has to be true for all of them. Okay, as soon as it's false for one, it's no longer part of the solution region. Okay, so you can actually stop and just say that. State 2 cases for using cosine law. So that would be all 3 sides known or side angle side. That's basically what I wanted there. State the descriptive form of a parabola opening up with a vertex of -3, 2. And note that descriptive look like this. You should have this on your study sheet, right? Minus h squared plus k. All right. So A you just make up, right? When it's asking you one of those, right? But it has to be opening up. So it has to be positive. So you can go 2. They don't mention narrow or wide, right? It's just positive. So A has to be positive. We make sure that is the case. When you bring this into the equation, you change the sign for the x only, right? Sorry, this is a 3, my bad. Right, so this -3 comes in here positive, and then it's plus whatever sign. Like if this had been a negative, you make this a negative. If the y is positive, you make it positive. So this would be an example, right? And it could vary. You could have 0.75 x plus 3 squared plus 2, right? As long as this is positive, you know that it's going to be opening up if A is positive. And this tells you that the vertex, no matter what, it's going to be -3, 2. That's where the vertex is for this particular parabola. Okay, so that's that. I hope that was a bit of a warm-up. And that was out of 15. Would have been out of 15, but I'm not taking this one in, okay? The next one, which is an open book AC, right? This is a question that walks you through. I'm gonna just pause my video and just together. Okay, so we're told that there's a developer that wants to subdivide, like break up a big property into smaller lots, right? Into 50 cottage lots on a private lake in Ontario. They can build either basic, right? Basic or deluxe cottages. That's a hint right there for the variables. A basic cottage costs 15 grand to build. Deluxe will cost 35 to build. That's obviously very simplistic. It's a lot more. They have $1,050,000 with which to build the cottages. When complete, the developer will profit $20,000 for a basic and $25,000 for a deluxe cottage. If the developer wishes to maximize profit, so there is that word maximize profit, meaning that you're gonna need to optimize and come up with the best solution. How many of each type should they build? Assign the variables of this problem. So let x be number of basic and y will be the number of deluxe. And both of them are cottages, right? It says the constraints and inequalities. You know what? We're going to do this up here. And so you get 1 mark for just assigning the variables. How's that? Okay. Write the constraints and inequalities for this problem. A chart table may help. That's only if you want to. And so what are the restrictions, right? If you go back up here, 50 cottages, that means that you can have a maximum of 50 cottages altogether. So the amount of basic and deluxe, it doesn't matter what combination. What is true is that it needs to be less than or equal to 50. Okay, so maximum of 50 cottages. So that'll be 1 mark. It says that a basic cottage costs 15 grand and a deluxe 35 grand, and they have this much to build, right? So that's the maximum. It can be up to that much, right? So the next one is 15,000 x plus 35,000 y, right? That's the cost. That has to be less than or equal to that 1,050,000, right? Maximum 1,050,000 to spend with which to build, it says, right? You zoom out a bit. So that's your next. And you know, this is 1, 2, and technically this goes in here, and so you get 3 marks. You get 1 mark for this, you get 1 mark for that, and you get 1 mark for that, even though this normally I wouldn't make worth 1 mark, but there it is. And we only have 4 minutes left, so this is probably not going to happen. Okay, we're not going to finish it in time. But because you're all home, it's okay if I go over a bit, right? Graph the inequalities clearly and label the corner points of your solution region. And what we're going to do is do what we always do, right? This is 50, 0, 0, 50. Rewritten, it's this shade above, and it is solid. Okay, we've gotten that out of the way, and then the next one, it's going to be a little bit more work. but you know how to do these already, like how to find the intercepts. It doesn't matter how big or small the numbers. So I'm just gonna give you what that is. The x-intercept is 70, 0. The y-intercept is 0, 30. So it works out quite nicely, right? So those are my intercepts. Rewritten, you get 35,000 y is less than or equal to negative 15,000 x plus this, right? And you divide everything by 35,000. Don't forget to switch the sign when you bring the x over, okay? So y is going to be less than or equal to, I always cancel the trailing zeros, okay, 1 for 1, and that works out quite nicely there. So this means it's a solid line, and below is true, so shade above. And you might ask, some of you might be asking, what about the 25,000 and the 20,000, Mr. Dirksen? Up there in the word in the problem, right? Like up here, it mentions that, but there is no restriction on the profit at all. It doesn't say want to make at least this much or anything. So that's probably going to be used for your objective function later on. Okay? So if you graph this, this is your basic, and this is deluxe. I'm rushing a little bit. That's the bell right there. Yeah, I figure I can't keep you for the next class if you have another class. So what I'm going to do is continue this tomorrow. Okay. So I'm just going to, because I was open book,